Welcome everybody. Today we're going to be talking about Service Mesh, and particularly we're going to be talking about Kuma. Kuma is, so first and foremost, my name is Marco Palladino. I'm the CTO at Kong. And Kuma is an open source service mesh that has been started by Kong in September 2019. And today it is the only Envoy-based service mesh that's part of the CNCF Foundation. It has been donated to CNCF as a sandbox project. And it's free to use, it's open source, and it's quite simple to get up and running with it. When we were looking at service meshes that we could use in enterprise environments, we looked at open source service meshes that were already available in the community, and we found out that most of those open source projects, they were not as easy as we wished they were. Service mesh has been a very complex topic for many users, for many customers of Kong as well. And we needed something that was tailored for the enterprise architect. We needed something that was simple to use, simple to deploy, simple to scale, something that was multi-mesh. An enterprise architect is going to be supporting multiple service meshes across different lines of businesses and different teams across those lines of businesses. So we needed something that an enterprise architect could provision quite easily across the entire organization. We needed something that supported Kubernetes as well as virtual machines. We needed something that was not available in the market. And so we decided to build Kuma open source and make it available to everybody in the community. Over the past 6 months, I have to say, I've been quite impressed by the adoption that we had in the community. Over 600% in the number of Kuma nodes deployed, 4,000% in the number of data planes that are being powered by Kuma, almost 500% in the number of virtual meshes that is managed by Kuma all across the world. And really, this kind of adoption also is being reflected by endorsements from both the community and from enterprise organizations that started to use Kuma as their service mesh. Service mesh really is something that every organization needs to start thinking of, especially as they distribute and decouple their software more and more in order to scale and drive more business. And really, the more distributed and decoupled our software becomes, and the more service connectivity we're going to be having. And we don't want the application teams to manage that service connectivity. We want to be able to abstract it away with something like Kuma. When it comes to service mesh, really, what we need to do is make sure that as we build more services, as we build more applications, we are able to connect all of these different components, all of these different services together in a reliable way, in a performant way. So really, service mesh allows us to connect services, discover them, and enable reliable traffic communication among all of them. Then once we have all of this communication, it obviously goes over the network, and the network is not secure by default. The network is unpredictable by default. So we want to make sure that we can encrypt our communication. We want to achieve zero trust security, and service meshes can help us with that. Service meshes, they bring back the connectivity use case. They bring that connectivity use case back to the right stakeholders within the organization, not the application teams, which should be focusing on building the apps and building something that their users wants to use, but the infrastructure architects. And so the infrastructure architects with Kuma can provision multiple meshes by using the same Kuma cluster, and then they can deploy these multiple meshes across the board, as well as being able to retrieve observability metrics and traces and logs that we can either push to a third-party system or we can visualize from the service mesh itself. So Kuma, from a 10,000 feet view, it is a universal service mesh. It's universal because it has first-class support for Kubernetes and virtual machines, not just for the data planes, but for the control planes themselves. Kuma, I'm also very proud to say that the community has been contributing to Kuma what's probably the most sophisticated single and multi-zone deployment that any service mesh out there has. It has been built with the enterprise architect in mind, with simplicity in mind, and it is vendor neutral as part of CNCF as a sandbox project. We are planning to climb the CNCF ladder and try to get Kuma in an incubated state as soon as possible. Kuma is a multi-mesh and service mesh, which means we can deploy one cluster of Kuma to create as many meshes as we want. Each mesh has its own certificate authority, so they're isolated from each other. It's easy to use, it's easy to scale, it's universal. We provide first-class support for Kubernetes, and also we support the virtual machines. Most importantly, with Kuma, we can mix and match Kubernetes and virtual machine workloads to enable a better journey to modernization across pretty much every organization. It implements a very powerful attribute-based policies that can be applied on top of any attribute, like the cloud vendor that we're using, the country where the service is being deployed. We can create as many attributes as we want, and we can then apply policy based on that. It's quite powerful. As well as it provides, like I said, the multi-zone connectivity in order to be able to support different clusters, platforms, different cloud vendors within the same mesh. When it comes to multi-zone, really, this is a topic that Kuma has invested a lot into. Kuma can run into different modes, can run in a standalone mode, where effectively the data planes are going to be connecting with the control plane, and it can run in a multi-zone mode, which is more tailored for more complex enterprise deployments. The global control plane is the control plane that will receive the policies that we want to apply across any mesh that Kuma is managing. And then we have the global remote control plane separation, so that each zone that we want to support, and a zone can be a platform, a cloud, a cluster, is going to be having its own remote control plane that is going to be accepting connections from the data planes being deployed in the same zone. So the global remote control plane allows for the propagation of service mesh policies across the board, and it also provides a very scalable service mesh, since the remote control planes themselves can be scaled horizontally across each zone. And then we abstract away service connectivity by using an out-of-the-box Kuma ingress and DNS resolver for determining how these services are connecting to each other. If I am a developer building a service and I want to consume another service, I don't need to know where the service is being hosted. It can be in another zone, can be virtual machine based, can be in another cloud. All I need to know is the service name, and then the DNS service discovery that's built in inside of Kuma will automatically resolve that service address with either an address of the same zone or the address of an ingress belonging to another zone. Kuma is platform agnostic. You can run this pretty much everywhere, and you can mix and match these environments. Like I said, this is a service mesh that has been tailored for the enterprise architect, and we're seeing lots of success in enterprise deployments, and it's open source and available for everybody to use. It's easy to use. It provides a GUI out of the box, native CRDs for Kubernetes, as well as a universal CLI, an HTTP API, a built-in GUI. And it's policy-based. There is a policy for pretty much anything. We're adding policies more and more. Kuma is built on top of Envoy proxy, but we abstract away Envoy so that in order to use Kuma, there is no expertise on Envoy that's required. And policies can be applied by using those attributes I just spoke about. And this can work across multiple zones as well. And we also provide an API gateway integration. You can use any API gateway in order to either accept connections at the edge. We have a gateway resource that we provide either for accepting connections at the edge, as well as for exiting, for mesh ingress and egress within a specific mesh that's being managed by Kuma. So really, this is a project that provides a full stack end-to-end connectivity for pretty much all sorts of use cases, the mesh use case as well as the gateway use case. And of course, as you know, Kong started a few years ago as an API management company first and foremost. And so this gateway integration, it's something that we've built and then donated as part of the Kuma project. So let's see a very quick demo on how to install Kuma. It's quite simple. Kuma has a Kuma Cattle CLI, so installing Kuma is as simple as piping this command inside of Kubernetes. And if we do this, Kuma is now being installed. And if we look at the pods in our new Kuma system namespace, we're seeing that there is the control plane running, and we can also port forward this control plane so that we access the GUI. We can access the GUI if you want to see what's going on into our system. It is quite simple to get up and running. Right now, Kuma is being installed. As a matter of fact, I am going to be running the GUI right now, and in the GUI, it's an empty dashboard. We have as many meshes as we want, but 0 data planes. So what we can do really is, deploying an application. Like I've created a very simple counter application that we can deploy. And then on top of this application, we can apply policies like mutual TLS to encrypt and protect everything by using the mutual TLS definition, which automatically, by the way, implements rotation and expiration and also provides a built-in certificate authority. Of course, we can also start provide our own root certificates and keys if we want to do so. And so if I look now at the Kuma demo, namespace, the app is being provisioned. If I go to the data planes here and I refresh, we can see that the data planes are coming online. As soon as the demo application is being deployed, these data planes will come online. There we go. So I can port forward the demo application to demonstrate the mutual TLS functionality, so that we can secure and encrypt all of our traffic. So the demo application is a simple counter application that increases a counter on Redis. So I can effectively simulate some traffic. And then what I'm going to be doing is generating a command to enable the mutual TLS policy by using kubectl apply, the same one that's available on the website. And if I do that, we'll see that the connection will stop working. And so we can enable the connection again by using traffic permissions. And traffic permissions will enable, in this case, traffic from all services to reach any other service. And if I do that, we can see how mutual TLS is now allowing the traffic to be provisioned again. So it's this simple to implement zero trust security with Kuma. And this is pretty much the experience that we're going to be seeing for any other policy or entity. We can also route traffic based on different zones. Let's say in this example, any service that's consuming database in AWS West, it's going to be going to the instance of database in Azure. So all that multi-zone connectivity is being abstracted away. You can search, you can download Kuma at kuma.io. You can connect with our community on kuma.io/community. It's open source. We have a GitHub repository. So I encourage everybody to go ahead and give it a try. We also have a Slack channel in case you have any questions. Thank you.